Have you ever really thought about what happens in those few seconds after you hit send on a payment? Well, today, we're pulling back the curtain on the secret language of money, and trust me, it's getting a massive, massive upgrade.
You know the feeling, right? You send some money, the app says instant, but then you wait for a few minutes, maybe even longer. It feels like your cash has just vanished into some digital black hole. So what's the holdup? Well, that delay happens because your payment isn't just a pile of digital cash. It's actually a really complex message that needs to be sent, understood, and checked. And for a long time, all the different financial systems were basically speaking slightly different dialects, which, as you can imagine, slows everything down. So, how do you get everybody on the same page, speaking the exact same language? In Canada, the answer is a huge upgrade to the entire financial system. It's called the Real-Time Rail, or RTR for short. This whole project is being run by an organization called Payments Canada, and it's all built around a new shared rulebook. The goal here is pretty simple, really. Get every single bank and payment system to speak the exact same financial language. So, what is this new universal language? It's a global standard called ISO 2022. Now, the easiest way to think about this is like a universal translator, but for money. It's a set of rules that lets different banks, different systems, even different countries communicate payment info with each other flawlessly and, you guessed it, instantly. All right, so what does a payment message written in this new language actually look like? Let's pop the hood, let's crack open the code, and see the anatomy of a real transaction as it zips along the real-time rail. Okay, so every single message, doesn't matter if it's sending $1 million or just a little system check-in, is wrapped in something called a Business Application Header, or BAH. I like to think of it as a digital envelope, and that BAH, that's the address label right on the front.
And here we can actually see that address label in action. This little piece of code shows the from field. See how it uses a unique ID? In this case, it's just 111. To know exactly which bank is sending the message, it's a super precise way to make sure there are absolutely no mix-ups. And inside that digital envelope, you've got different kinds of letters for different jobs. A PAX.008 is the big one. That's the message that actually moves your money. A PAX.002 is kind of like a tracking update for your package. And then you have these admin messages, like adme.004, which is just the system saying, hey, I'm online, and adme.002, which is the system saying, whoa, something's wrong here, I'm rejecting this. Now, to understand these messages, you just need to know the two main players in this whole drama. In ISO 2202, a bank or any financial institution is called an agent, and everyone else, you, me, your local coffee shop, is called a party. Simple enough, right? Agent is the bank, party is the person or the business. And here's what an agent actually looks like in the code. This is the instructed agent, which is just a fancy technical term for the bank that's receiving the money. You can see its whole identity is just boiled down to this simple, unique member_identification number. Clean and efficient.
Okay, now let's look at a party. In this case, it's the creditor, the person or business getting paid. And this is where things get really cool. Look how much more data this new system can carry. It's not just some cryptic account number anymore. The message can actually include rich details like a full name and address. That is a huge leap forward for things like record keeping and fighting fraud.
But with all this new, rich data flying around at the speed of light, how does the system make sure there are no mistakes? Well, it has a built-in grammar check, a really strict set of rules that every single message has to follow, to the letter.
And I mean, these rules are incredibly specific. Just take a look at this one, RO4. It says the business_message identifier from the header has to match the message_identification from the message itself. Now that sounds like a bunch of technical jargon, right?
But it's actually super simple when you think about it. All it's really saying is that the tracking number on the outside of our digital envelope has to be the exact same as the tracking number written on the top of the letter inside. It's a simple, brilliant check to make sure nothing ever gets mixed up.
Okay, so let's see how this all works in the real world. Here's a common message called a heartbeat acknowledgement. It's basically one part of the system just pinging another to say, hey, I heard ya, I'm online, and I'm ready to go. You can see it has the sender, the receiver, the matching IDs, all following those strict grammar rules. The big question is, will the system accept it?
And yep, it passes. Because every rule was followed perfectly, the system gives it the green light. This simple check happens millions of times a day in milliseconds, and it's what keeps the entire payment network stable and trustworthy.
So, we've seen the secret language, we've looked at the grammar.
we've watched the validation check. But why does any of this technical stuff actually matter to you? What does this real-time revolution really unlock for all of us?
Well, for one, this system is constantly getting better. Just look at this timeline. The specs are updated every year, they're adding better tracking, stronger security, and in 2025, they're shifting over to the more modern and flexible JSON data format. This isn't some old, dusty system. It's designed to evolve.
So what's the bottom line here? What does all this tech actually get us? It means true, near-instant payments running 24/7, 365 days a year. It means richer data, like a full invoice, can travel with the payment. And maybe most importantly, it creates this secure standard platform for all sorts of new financial apps and services we haven't even dreamed of yet. So all of this brings us to one last big question. We've managed to transform money from just being a number into being a smart, data-rich message. So, what's the next instruction we're going to put inside that digital envelope? What are we going to teach our money to do next?